Good evening, everyone. My name is Saida Said, and this is our ninth interactive session. So last, 1 second. Okay. So last week we were talking about retaining structures. Last week we were doing this, and this week we will be talking about pile foundations. So let me talk a little bit about pile foundations before we move on further to the questions that I have uh, prepared. Okay, so obviously we uh, there are some conditions in which shallow foundations do not work, and we require pile foundations. So it may be when one or more of the upper soil layers are highly compressible and are too weak to support the load transmitted by the superstructure. We will have something like a soft strata, and then we will have a hard strata here, maybe bedrock, and we will have weak soil here, and we need to build a superstructure here. So what we do is we design the foundation so that it can bypass the load it is carrying through these weak layers up to a strong layer. Okay, so that is one condition where weaker top layer. Another condition is where bedrock is not encountered at a reasonable depth below the foundation, um, like uh, uh, it's too deep, or when the structures are subjected to horizontal forces. These can be wind forces, these can be water forces. For example, if we have a, excuse me, I don't know what's wrong with this today. Okay, so if we have a tower structure, a high rise building, and the wind may create these, okay, so the wind may create this force at top, which may result in a moment at bottom, or it can be a structure like a bridge abutment in which is underwater, which we construct underwater, and there is high pressure due to water flow. There we may need pile foundations. We also need pile foundations when we have expansive and collapsible soils at the site. Because these do not perform, like our foundations do not perform very good in these soils. It can create uh, problems at higher depths. low depths. So we need a pile foundation in this case. Or we need when structures like transmission towers or offshore platforms or basements below mats below the water table are subjected to uplift forces. If there is an uplift force on a building, so you can say. So basically, what we are saying is that there are some conditions where shallow foundation is not suitable, and hence we need to provide these pile foundations. Okay, so you have gone over the classification of piles and what are the types of piles in class. We will not discuss that. Just briefly, we will discuss the mechanism of load transfer in piles. Not even pile driving. I know it has been discussed in class, and we will discuss the mechanism of pile load transfer so that we can tackle these questions ahead. So there are based on the mechanism of load transfer, we can classify the piles as void bearing piles, friction piles, or compaction piles. So when we talk about a pile, it is a long structure and it has some load on it. So there are two types of load transfer mechanisms. One, if you see, if this material has good frictional resistance along this shaft of the pile, this there will be a frictional resistance along this shaft that is the first mode of transmission, and that is what happens actually when you load. First, the load is transferred through this, is dissipated, we can say, through this friction. And if the frictional resistance is less than the load, we are the stress that we have put over this pile, then we can say then this end of the pile, we can say it acts like a not a shallow foundation, but the mechanism of load transfer is like this shallow foundation, because here now it will stop the penetration of this pile, not because of friction, but because of end bearing resistance. So we have two load transfer mechanisms. There is friction and then there is end bearing resistance. Now, friction will be there only if there is a significant amount of frictional, per unit length, there is significant friction. And end bearing, uh, what happens is that usually piles in a mixed strata, a mixed type soil, they will encounter both types of load transfers. But if it is a specific a type of soil, like it's clayey soil or it's sandy soil, based on that, either most of the load can get transferred through frictional resistance or most of it can be transferred through end resistance. So if frictional resistance, let's call this Q, end resistance, if friction is much greater than Q, then we call it frictional pile. And if end bearing is much greater than F, then we call it end resistance piles. And if there's both, so it's just a pile. So basically in this what we do is in friction, in calculating the frictional resistance, we just say if F is the frictional resistance per unit length, not exactly length but per unit area, let me say. So what we do is calculate this at a unit area, we calculate F, and then we multiply it with the whole area that is resisting the friction, the load. So for a cylindrical uh, pile, it will be just the perimeter multiplied by the length. So we are taking this area, actually curved surface area. For example, a square pile, it will just be again perimeter multiplied by the length of embedment. So what this is the unit frictional resistance, and then we just multiply it with the area. And for end bearing resistance, we do exactly how we do it in the shallow foundation case. We go with the bearing capacity formula, which is CNC, oh sorry, plus QNQ plus half of B gamma and gamma. Now you see here B is very small as compared to the length. Here, if we talk about Q is much greater because it is gamma times L, and L is much greater than RB. So most of the times we do not take this term and we only proceed with these two terms in our calculations. And then the total resistance will be the resistance due to friction and the resistance due to end bearing, and maybe we will divide it with the factor of safety based on our requirement. Okay, moving on. So the methods, so this is the important part, the methods of determining the ultimate bearing capacity of single piles, let us talk about first, then we